Hi everyone, this is Chapter 5, Polynomial and Rational Functions, Section 5.3, Graphs of Polynomial Functions. In this section, students will recognize characteristics of graphs of polynomial functions. Students will use factoring to find zeros of polynomial functions, so get ready to factor, one of my favorite things to do. Identify zeros and their multiplicities. Determine end behavior. Now, we've already talked about end behavior in section 5.2, so this will be somewhat of a review. Understand the relationship between degree and turning points. We also talked about turning points a little bit in 5.2, so again, more review. Graph polynomial functions and use the intermediate value theorem. Okay. So we want to talk about recognizing characteristics of graphs of polynomial functions. So polynomial functions of degree 2 or more have graphs that do not have sharp corners. So that's important. Polynomial functions do not have sharp corners. Polynomial functions also display graphs that have no breaks. So that's another important feature that we need to remember. No breaks. Curves with no breaks are called continuous. Figure 1, right here, shows a graph that represents a polynomial function and a graph that represents a function that is not a polynomial. So let's look at these. So this looks like it's a smooth curve. It doesn't have sharp corners. It doesn't have any breaks. So I would say this here is a polynomial function. It's smooth and it has no breaks. But let's look at this one. This one's smooth, but look here. It's broken right there. So this is not a polynomial function due to the breakage here. So it has a break in the graph, so it's not a polynomial function. All right, so why don't you pause the video and look at these 4 graphs and decide which of the graphs are polynomial functions and which ones are not. And when you unpause the video, we will go over the answer. All right, hopefully you looked at these. Let's look at this first one. This one looks like smooth curves. It looks like it's continuous. So I would say this one is definitely a polynomial. All right, let's look at the next one. This one has a sharp corner right here. It's a sharp point right there. So you can't have sharp corners, so that's not a polynomial function because it's not smooth and it has a sharp corner. Looking at the next one, this one looks smooth and continuous, so this one is a polynomial function. What about this last one? You can see right up front there's a hole in the graph. So because there's this hole in the graph, it's not a polynomial function. Okay, so again, polynomial functions, they have smooth curves, no breaks, no sharp corners. All right, so now we're going to start talking about finding zeros of functions, of polynomial functions. Now, if you will recall, a 0 is the x-intercept. It's where the graph crosses the x-axis. So in this example, we want to find the zeros or the x-intercepts using a graph. So you can actually look at the graph and determine what the intercepts are. So here's one, and here's one. So our intercepts are, it looks like 1, 2, -3, 0, and -2, 0, and 1, 0. So our zeros are x equals -3, -2, and 1. Okay, and the cool thing is if you have something like Desmos and you graph, you can just click on the x-intercepts and it usually will show you what those are. So that's a nice feature of Desmos. All right, so now let's look at it when we don't have the equation graphed. So it says find the x and y intercepts, and we talked about this a bit already, I believe. So to find the y-intercept, remember we set x equal to 0. And to find the x-intercept, we set the y equal to 0. So I'm going to do g of 0 for the y-intercept. So that's 0 plus 3 squared times 0 minus 2. So I will get 3 squared times -2. So that's 9 times -2, and we get -18. So that's the point 0, -18 for the y-intercept. And then for the x-intercept, we set g of x equal to 0. So y is the same as g of x. Okay, so we are going to, for this one, we're going to set each of the what's nice about this is it's already factored. So to solve it, we just set each of the factors equal to 0. So for this one, if you square root it, it ends up being x plus 3 equals 0. We get -3. Here we have x minus 2 equals 0. Add 2 to both sides, you get positive 2. So my x-intercepts are -3, 0, and 2, 0. So if it's already factored, the x-intercepts are pretty easy to tell. Let's look at Desmos. X plus 3 squared, x minus 2. I just want to show you that Desmos is pretty awesome. Alright, so if I put in y equals, what was it? I believe it was x minus 3 squared, and then let's just double check. X plus 3 squared, x minus 2. So let me fix that there. X plus 3 squared, x minus 2. Alright, so you can see these points. You can see here's 1 point, -3, 0. Here's 2, 0. Those are the x-intercepts, and then you can see the y-intercept is 0, -18. So the same thing that we got, and you can kind of zoom in on the different pieces so that you can get a better look. You just click on it and it'll show you what those points are. So algebraically, you can find, algebraically you can find the zeros, or graphically. All right, so graphically, let's talk about using factoring to find using factoring to find zeros. So let's look at those steps. So first things first, if they ask you, given the polynomial function f, find the x-intercepts by factoring, first thing you're going to do is set f of x equal to 0. Because you're finding the x-intercepts, and that's what you do. You set the y or the function equal to 0. So if the polynomial is not given in factored form, then you're going to factor out any common binomial factors. So basically, factor out the GCF, and then you're going to factor out any factorable binomials or trinomials. And then once you do that, you're going to set your factor equal to 0 and solve to find the x-intercepts. So basically, you're going to put it in the form that we just had the previous one in and set each of those factors equal to 0. Alright, so let's look at one. Find the x-intercepts of f of x equals x to the third plus 2x squared minus 9x minus 18. So this is where you're going to set the f of x equal to 0. And this is where it's really helpful if you can remember factoring. So for this one, I would group together binomials. So I haven't done anything other than put parentheses into this expression. I grouped together x to the third plus 2x squared, and I grouped together negative 9x minus 18. I put them in parentheses to show that they're in groups, and I put a plus sign in the middle. And now I'm going to factor out a common binomial, which just means factor out the GCF of each of these groups. So I end up with 0 equals, looking at this first pair, x to the third and 2x squared, what binomial or what greatest common factor do they have in common? Well, it looks like they both have an x squared in common. So if I factor out an x squared, you ask yourself, okay, what do I multiply times x squared to get x to the third? And that would be x. And what do I multiply times x squared to get 2x squared? And that would be 2. So I have taken this expression and I've factored out the x squared that they have in common. And so if I were to go backwards, x squared times x is x to the third, x squared times 2 is 2x squared. So it is the same expression but in factored form. Alright, so what do these two numbers have in common? Negative 9x and negative 18. Well, they definitely have a negative in common. And 9 will go into both 9x and negative 18. So I'm going to factor out a negative 9 and then ask myself, okay, what do I multiply times negative 9 to get negative 9x? And that would be x. And what times negative 9 would be negative 18? And that would be positive 2. Now, looking at this, hopefully you can see that these two have a common factor of x plus 2. So if I factored out an x plus 2, what would be left? What would you multiply times x plus 2 to get this expression there? You would multiply it times x squared. And then to get this expression, you would multiply it times negative 9. Now, I'm not finished because hopefully you'll recognize that x squared minus 9 is difference of squares. So again, you might want to go back and review and brush up on some of your factoring. So if I were to factor x squared plus 9, that factors into x plus 3, x minus 3. So now that it is factored, I'm going to set each factor equal to 0 and solve. So here I get negative 2, here I get negative 3, here I get positive 3. Because again, all you're doing is, for this one I subtract 2 on both sides. For this one I subtract 3 on both sides. For this one I add 3 on both sides. So that's where those answers came from. So our final answers are the intercepts negative 2, 0, negative 3, 0, and positive 3, 0. So let's check Desmos and make sure we get the same thing. All right, so we had x squared, let's see, plus 2x squared. Oh, x to the third, So let me fix that. X to the third plus 2x squared plus, no, it was minus 9x minus 18. Okay, and it asks for just the x-intercept. So look, there's the negative 3, 0, negative 2, 0, and 3, 0. So all of those you can also see on the graph there. Yeah, this one did not ask us to find y-intercept. So if it did, the y-intercept would be negative 18 if you plugged 0 in for the x's. Okay, so we're going to stop the video here and pick up with part 2, where we will talk about identifying zeros and their multiplicities in the next video.